Have you ever imagined how a weapon that requires no gunpowder, accelerating projectiles to thousands of meters per second in an instant using only electrical energy, could completely transform the landscape of naval warfare that has persisted for centuries? Not long ago, this scene transitioned from science fiction to reality. Within the barrel of the Type 055 destroyer Nanchang, a 32 megajoule high-energy pulse was unleashed. A tungsten alloy projectile sliced through the sea surface at astonishing velocity, precisely striking a target 270 kilometers away. This successful sea trial not only signifies China's entry into a new era of kinetic energy weapons for naval platforms, but also heralds a rewriting of naval warfare rules by this national strategic asset, slated for mass deployment by 2027. The core breakthrough of the electromagnetic railgun lies in its revolutionary energy conversion method. It completely abandons the traditional artillery model reliant on chemical energy propulsion, instead utilizing megampere-level currents interacting with magnetic fields to generate Lorentz force, directly converting electrical energy into projectile kinetic energy. This conversion process achieves an efficiency of up to 95%, far surpassing the 70% efficiency of conventional artillery. The muzzle kinetic energy of 32 megajoules equates to the instantaneous release of 7.6 tons of TNT equivalent, sufficient to propel a tungsten alloy projectile through 10 meters of reinforced concrete and effortlessly penetrate the composite armor of modern warships. Its destructive capability exceeds that of a 120mm tank gun by more than fivefold. Its extraordinary 270-kilometer range elevates the coverage of conventional naval guns, typically limited to 30 kilometers, by an order of magnitude, truly achieving the strategic objective of beyond visual range precision strikes. Even more astonishing is that China's electromagnetic railgun launches not conventional iron projectiles, but programmable warheads equipped with intelligent guidance systems. These warheads integrate miniature navigation modules, attitude control engines, and target recognition chips, utilizing a triple guidance mode combining Beidou 3 satellites, millimeter wave radar, and infrared imaging. They can lock onto targets even under intense electromagnetic interference. During a July 2025 anti-missile test, an electromagnetic projectile pursued a hypersonic target, simulating the DF-17 at Mach 7. Activating its attitude control engine at a distance of 1 kilometer from the target, it executed serpentine maneuvers to adjust its trajectory, ultimately destroying the target through direct impact. At the tactical level, intelligent coordination and dual offensive-defensive capabilities form the core strengths of the electromagnetic railgun. Its AI-powered ballistic correction system integrates with shipborne radars and satellite positioning systems to dynamically adjust projectile trajectories in real time. This enables precise targeting against high-speed maneuvering targets, achieving an intercept success rate reportedly exceeding 90%. Offensively, it can launch land strikes beyond enemy anti-ship weapon ranges, effectively covering critical facilities like ports and missile sites. On the defensive front, its theoretical rate of fire of up to 60 rounds per minute enables dense barrage deployment, effectively intercepting saturation attacks like cruise missiles and drone swarms. With a per-round cost of approximately $25,000, less than 1% of anti-ballistic missiles, this integrated offensive-defensive capability significantly enhances the Type 055 destroyer's overall combat effectiveness. As a formidable combat platform, the Type 055 destroyer provides critical support for the operational deployment of electromagnetic railguns. As China's first 10,000-ton class destroyer equipped with an integrated power system, the Type 055 possesses ample instantaneous power supply capacity, successfully resolving the energy consumption challenges associated with electromagnetic railguns. Its modular design also enables rapid maintenance and component replacement for weapon systems. Compared to the US 32 megajoule project, which was suspended due to power shortages and rail wear, China has not only overcome technical bottlenecks like rail ablation and ammunition stability, but also achieved mature adaptation to shipborne platforms, with barrel life exceeding 5,000 rounds. Analysts note that China's electromagnetic coil gun technology eliminates direct projectile rail contact, completely resolving the barrel ablation issues caused by friction in US railguns. It maintains stable accuracy even after firing 120 rounds consecutively. These technological breakthroughs did not occur by chance. At the Second National Electromagnetic Launch Technology Forum, which concluded in August 2025, China's electromagnetic launch technology was confirmed to have achieved systematic breakthroughs in multiple critical areas. Its technological development has demonstrated a leapfrog trajectory, progressing from catching up to keeping pace, and then gaining a leading edge in certain fields. Professor Liu Juniang from the Naval University of Engineering stated that China has made significant progress in fundamental research, key technologies, and engineering applications, including overall launch design, pulse energy storage, electrical power regulation, and linear propulsion. The imminent deployment of this electromagnetic railgun is expected to profoundly alter the maritime power balance. It positions China as the first nation to conduct operational testing of a ship-based electromagnetic railgun, disrupting the traditional dominance of missiles in naval warfare. Following mass deployment in 2027, the Type 055 destroyer fleet will establish a multi-layered offensive-defensive system combining missiles and railguns. This capability enables both precision strikes at ultra-long ranges and the creation of low-cost defensive barrages. In missions such as distant maritime rights protection and aircraft carrier escort, this weapon will significantly enhance the Chinese Navy's area denial capabilities, becoming a formidable deep-sea blade for safeguarding maritime interests. Unlike traditional carrier warfare concepts, the Type 055, equipped with railguns, can deliver firepower beyond the operational radius of carrier-based aircraft. Its 300-kilometer range, combined with smart warheads, enables simultaneous strikes against multiple targets including enemy vessels, airfields, and command centers. In missile defense, it fills gaps in traditional missile systems' mid to terminal defense phases. Its low cost, high rate of fire capability creates dense intercept networks to counter saturation attacks by hypersonic missiles. Crucially, it eliminates the need to store flammable and explosive propellants, drastically reducing the risk of ammunition magazine explosions and boosting ship safety by over 50%. This integrated offensive-defensive capability is driving the Navy's transformation from carrier-centric warfare to firepower-centric warfare. Internationally, China's electromagnetic railgun development path demonstrates distinct latecomer advantages. Although the U.S. Navy initiated its railgun project as early as 2005 and completed prototype testing at 32 megajoules in 2010, it ultimately announced an indefinite postponement of the program in 2020 due to unresolved challenges in shipboard power supply and rail ablation. In contrast, China adopted a more pragmatic, incremental development strategy, first resolving fundamental theoretical issues, then overcoming key technological hurdles, and finally achieving system integration. This steady, step-by-step approach ensures the project's sustainable advancement. In terms of combat effectiveness, electromagnetic railguns are redefining the kill chain in modern naval warfare. Their projectiles travel at extreme velocities, reaching targets 200 kilometers away in under 2 minutes, dramatically shortening the kill chain duration. Simultaneously, the immense kinetic energy generated by these ultra-high velocities eliminates the need for explosive warheads. Projectiles achieve devastating effects solely through impact, a purely kinetic kill mechanism that revolutionizes traditional weapon destruction principles. From a strategic perspective, the deployment of electromagnetic railguns will significantly enhance the Chinese Navy's blue water warfare capabilities. In safeguarding national maritime rights, protecting sea lanes of communication, and conducting distant sea defense, the railgun's unique performance advantages will make it a crucial instrument for upholding national interests. Its ultra-long range allows vessels to engage enemy targets from relatively safe distances, substantially improving operational flexibility and survivability. Looking ahead, as the 2027 mass deployment milestone approaches, the electromagnetic railgun will undoubtedly leave an indelible mark in the history of naval armament development. It represents not merely a new weapon system, but a revolutionary shift in warfare doctrine and an innovative path in technological advancement. Amidst the distant ocean waves, this electromagnetic-powered naval warfare revolution is quietly unfolding, and the Chinese Navy has already secured a leading position in this transformative era.